Okay, so to start off, chapter 4, let's see, I assigned problems 6 through 11 for the homework for tonight. So those of you that are actually going to do this, it should help you with number 8, 10, and 11, I think was the suggestion for the ones that I could go over. The first one, I just want to point out really quickly. Multiply the expression below using an area model. A should be pretty easy. B, it's squared, so that means you're going to have 2 of them. And then you should be able to set up a 2 by 2 for this one also. And then for write the area of the rectangle at the right as a sum and as a product. So it gives you the information inside. You need to come up with what's the product on the side, what's the product on, actually I should say, what's the dimensions of the side, what's the dimension of the bottom, and then write it up as a product. And then collect like terms for the inside so you can actually get the sum written out correctly. And then problem number 8. So problem number 8 is actually fairly easy. Maybe D might be the more difficult one. It's just basically reminding you that if you have 12x plus 18, you really have a 6 that you can factor out between the 12 and the 18, because 6 is the greatest common factor between 12 and 18. And then for the next one, the sum is x squared plus xy plus x, and I'm going to zoom in really quickly so you can see what I'm talking about. For this one right here, you have 2 x's for the first term, 1 x for the second term, and then just 1 x for the third term also. So you really have a few x's that are in common to all of them, and if you were to distribute, this is your product, this is your product. So if you're going to distribute, you get x squared plus xy plus x. A, B, and C shouldn't have a problem. 4x plus 8, what do they both have in common? What do the two terms have in common? What's the highest number between a 4 and 8 that it has in common? What's the biggest number between 10, 25, and 5 that all three have in common? Here, you have a 2 in common between a 2 and a negative 8, but is there something more? Hint, look at the variable. The last one is probably the one that I'm going to actually do with you guys. So we did this in tutoring today, and what I told them to do was tell me, okay, well, you have 3 terms, so realistically you have something that looks like this when you put it all through. So you have 9x squared y, you have 12x, and you have 3xy. Okay. Now the question is, what did they all have in common? What do all 3 terms have in common? The best way to look, number 1, is look at the numbers. What do 9, 12, and 3 all have in common? And the answer would be, well, they all have a 3 in common. Okay, well, is there something else? What variable do they all have in common? Well, there's 2 x's here, there's an x here, there's an x here, so we're going to say, okay, well, they all have a 3 in common. An x in common. Well, then, the last question is, what should go down here so that when you multiply 3x by whatever term you come up with, you get 9x squared, so 2 x's and a y, and then 3x times what gives you 12x, 3x times what is going to give you 3xy, and so those are your products. So in the end result, you should have 3x times something else written down at the bottom. That's your product, because you already have your sum. Okay, so that was number 8. Sorry, that was really fast for number 8, but I'm sure you can review the video if you need to. Number 9, I was told the hints on the website should be okay with number 9, so you don't need it. Number 10, a relationship between inputs and outputs is a function. If there's no more than one where there is no more than one output for each input. Those of you for last year who had Math 1, if you remember the soda machine problem, so the one where if you pressed the button for a soda machine, you basically had to remember that if you pressed the can of, I don't know, I think it was Slurm or something like that, Slurm had to come out every time that you pressed the button for Slurm. Or if you press the button for Slurm, I don't know, Mr. So-and-so needed to come out. So you could not have, if you go to a soda machine, if you press the can of Diet Pepsi should typically come out. If you press the button for Diet Pepsi again, you shouldn't get, Coke out. It's just not going to work that way. So it needs to, every time you press a button, it needs to be consistent. That was the name of the game. So if you look at part C, think of it like, okay, well, I'm going to press a -8 and I'm going to get a -4. Okay, that's fine. I'm going to press a -1, I'm going to get a -3. Okay, there's no inconsistency so far. I'm going to press a 0, I'm going to get a -2. I'm going to press a 1, I'm going to get a -1. I'm going to press an 8, I'm going to get a 0. So this is consistent. What it would fail if it wasn't consistent is if, for example, you also had a -1, let's say, and you got out, I don't know, a 5, let's say. These two are not consistent. Whenever you press a -1, whenever you press a -1, you should always get the same information out. You can't get two different things that pop out whenever you press the same button. Okay? So looking it from this standpoint, you cannot have more than two of the same X values that'll give you different Y values. And so you can take that to this for part B. If you look at part B, 1 as the X value hits the graph up at the top, and then it also hits the graph down here at the bottom. That's inconsistent. These two here, this button, this output here and this output here, have one input for X. So B is not a function. Okay, C is a function because all the numbers that they gave us work out just fine. Okay, and the same thing for A. A is also a function only because if I go here at 1, I'm only hitting the graph one time. If I go here at -2, I'm only hitting the graph one time. If I go here at +2, we're only hitting the graph at one time. So you can think of it like, well, here for part B, you think of a line going up and down. I'm really hitting the graph 2 times whenever I think of this line that's going across. It's hitting it twice. But for a parabola, I'm really hitting it just kind of like one time. So that does make it a function because for every single input that we have, we only have one output, or one Y value, I should say. Now, for D, it's the same thing. So we have one input, and then you have one output that comes out for a line. A line is always a function. Well, actually, I shouldn't say all lines are function. Most lines are functions. I'll let you think about which line is not a function. So this one checks out, this one's good, and then A is good also. Alright, so you have 3 that are functions, B is not. So that's 10. This is way back in Math 1 stuff. And for, let's see, 11, I'm at 8.5 minutes already, so let's see if we can do this pretty quickly. The best thing I can say to do for 11 is draw an area model. This will help you out. If you don't want to do an area model, you're more than welcome to do a tree diagram, but this is my biggest I push the area models a little bit more than the tree diagrams. So at Lara's school, 25% of the student body is male. So the question is, if 25% of them are male, what percentage are female? Okay, well, hopefully you're thinking in your head it's about 75%. And then 40% of the students walk to school. Okay, so we're going to have walk to school, 40%. And then I'm going to say don't walk. Don't walk to school is going to be about, 60%. All right, so I'm going to wait 5 seconds, okay? And what I need you guys to do is I need you to fill this in. And so based on your information, you're going to calculate what's the probability that the student is a female. Okay, well, you have that answer. It's going to be 75% of your population is female. That's just asking you to make sure you understand that you're not you have more information to put in your square than just 25% male and 40% who walk. You need to understand that 25 and 75% together make 100% of your gender population at your school. All right, so 75% of them are going to be female, or better known as 0.75. Depends on which way you look at it. Same thing. Which population is a male and then does not walk to school? So this is your and you have an intersection. So you're looking at the intersection of what's a student male, okay, 25%, and does not walk to school. So that's 60%. So this right here is whatever answer you've come up with. I'm not going to do the work for you. This is your intersection of 25% is male, 60% is don't walk. And you got to calculate the probability of that. It will be a decimal, or then you can change it to a percentage. Okay, and then this part C, it says student walks to school or does not walk to school. Well, you are more than welcome to. You can do probability of walks to school or probability doesn't walk to school. Okay, and we had an actual addition rule that goes with that. You can set up probability of walks to school plus probability of doesn't walk to school minus the probability of walks to school times the probability of doesn't walk to school. Okay, now when you do all this fun, awesome, and exciting work, so probability of walks to school is 40%, 0.40, plus probability of doesn't walk to school 60%, right? Or 0.60 minus, let's see, 0.4, right? Times doesn't walk to school times 0.6, 0.6. I always forget my leading zeros. Okay, you can do all that fun stuff here. Okay, then you have 0.4 plus 0.6. Then you have, let's see, 0. What? This is just 1. 0.00 minus, whatever this is. I don't have a calculator on me. 0.4 times 6 is 24. 24. So your answer should be 0. Oh my god, I can't do stuff in my head to save my life. There's a 6, carry the 1. So we have a 7. Sorry, there you go. 76.24, right? Does that work out? Yes, that works out. Okay, so about 70% of your population either doesn't walk to school or does walk to school. Okay. Now, the last one is identify the sample space in part B and C above as a union or an intersection. So you need to go back into your notes, okay? And which one of them is your union, one of them is your intersection, and figure out from there. And hopefully maybe the information on the CPM web for homework should help you out. So if there's any part of this that you didn't understand or I did something wrong, I'm literally doing this on the fly. So leave me your comments and your questions at school tomorrow. Okay, bye.